In this video, I'm going to go into a little more detail on some of the functions in Spreadsheet view and how we set up each of our components. So as you can kind of see in the background here, this part number, it's 666443. And if you click on these patterns that we've set up using the train PatMax pattern function, you will see kind of how they were set up all over the board. And so you'll also notice that there's some different colors here that I've used. So the blue color is going to be anything that was set up in this first orientation. Now, ideally, the orientation that you set up on here will be the same orientation that it will be in on the panel. And then as the color changes, it'll be either 90 degrees, negative 90 degrees, or 180 degrees of rotation from that initial position. So the reason we did these different rotations is because sometimes Cognex needs multiple pictures of parts to properly identify them. And that kind of goes back to the score that we said. We can lower the score, but we like to keep it high. We want to make sure that it's accurately identifying all the parts. And the more parts you add, the more you may need to verify that it's accurately identifying them. And so, sorry about that. So, as we showed you before, train PatMax pattern. This is how you train your pattern. Find PatMax pattern. You'll use that to find the pattern. And so you see down here our instance, the 666443-9. This one is the first instance where it actually finds the pattern. And so the next part down was the transfixture world, which puts these coordinates in real world coordinates. And then once those things are done, I'll kind of go on to explain the rest of how we send the data onto the robot. So most of this is automatically generated. The first thing that we actually go in and do after these three, so the train PatMax pattern generates these two cells, the find PatMax pattern generates all of these cells, then the transfixture world gets all of these, excluding this one, and then the rest of the stuff over here, some of it's blank so you don't see it, but I'll click it in the cells and kind of explain how they were created. So this cell right here is kind of this is a logic function. It's checking to see for, and this is really only applicable to any of the rotated patterns. So for anything in blue, it shouldn't be a problem, but for anything in pink, purple, or green, you may see a problem where this goes outside the range of 360 degrees. And so right here, this actually doesn't throw an error because it is negative 251, but that's because we're adding 90 degrees here. So if we were to go in and say, make this negative, add negative 90 degrees, now it's at the negative 431 degrees, and it neutralizes it back to within the range of negative 360 to 360, which our robot can deal with. It cannot handle things larger than that. So we'll go back because this is plus 90. Yeah. So our next step, so once we've set this up, so basically it's saying if this cell right here is greater than 360, or if it's less than negative 360, it's going to take the absolute value of it and then subtract 180 degrees. So that's just some math to neutralize it. You should understand if you've taken any trigonometry classes. So this next one over here is concatenating the data. So up here, this is our M. This cell on every single part, it's all the same. This one is blank right now because this part is not identified in the workspace. Same with all of the other ones in here, just this one. So basically, we want to send data a specific way to the robot, and the way that we have it sending is going to look, you can see right here, the part number, specifically which instance of the part number, and then separated by a colon, and then in parentheses it's going to be, or kind of the curly braces, we have the row, the column, and then the angle. And so, unfortunately, Cognex does not have a very nice way of, or the Insight does not have a very nice way of interfacing logic. So we kind of have to, we can't do any nested if loops or if statements, so we have to kind of link things together. But so basically we'll work backwards to create this cell, which is getting all of the data concatenated. We have to verify that it actually is finding something. So we don't want to send the robot every single part. We only want to send it the parts that are there. So this cell right here checks the length of, so if you click on it, you can actually see which cell it links to. So it's checking the length of this to make sure there's actually a part number there. So as you see up here, there is no part number, so the length is 0. Well, so here, so the length is 0 because there's no part number here. Well, there's no part number here because the part wasn't found. And how we set this logic up was we have an if statement and it says if error free. And so error free is pretty much the easiest function to use in your if statements. So checking to see if this errors out. And this would be the first image we took of this part. And so this errored out. So it's going to make these two cells blank, or it's going to check down here to see if this one's error free. And it's basically going to go down the list. So it's going to check, did this part get found? Did this part get found? Did this part get found? Did this part? And so as you see, we found the instance of W666443_9 is the first time we found this part. And so this was the only one that was a match. So it's going through each time, it's iterating to find until we find the part. So once it finds this part, basically we don't care about any of this data. We only care about these two cells. We just need all of these here based on how the Insight software works. And so we take these two cells, and if these are correct, we concatenate them here, which is grabbing, this is the part number and this is the location, concatenates those two, and then as long as something passed, we send it all right here and put it in the, and this is just putting in the format that we want. And once that's completed, we call that down here in our write device. So for some reason at the moment it's erroring out. I may have done a mistake in here. So basically our TCP device, this is going to take, you can kind of click on it, we'll open it up. So our TCP device is for the networking. And so you put, your host name, port, protocol. Most of this can just stay default, but you will have to put in your host name and the port. And then here for your write device, we put in the image. So A0 is the acquired image. Every single time you click this trigger button and it updates, that image is stored in A0. So that's important. And then N83 down here was our TCP protocol device. And then each of these are these cells, the M cells, where the concatenated data is saved. So each of those, you'll have to do it for every single one, and if no data is found, it will just send blank data. It's not going to send that to the robot. So basically, if we were to take this image right now and try to run our program, it's only going to recognize this one part, the 666443, and so it'll only be sent specifically this data, which is part number, row, column, and rotation. So that is it. As far as setup, you can kind of, if you want to go through, kind of click in and look at some of the different statements, logic we did, but it's pretty straightforward, just a little tedious since it has to be done for every single part, but that's about it.